Here we have a problem on derivative. So there is a function given over here, that is y equals to x over cosine x, and we have to find dy over dx. That is, we have to find the derivative of the given function with respect to x. And also we have 4 answer choices. Okay, here in the given function, we have variable x in both numerator and denominator. Whenever I want to find derivative of a function which contains variable in both numerator and denominator, I have to use coefficient rule. What is coefficient rule? Okay, first let's understand what is coefficient rule. Okay, let's consider a function which contains a variable in both numerator and denominator. So that is, here we have to assume both u and v are variables, and I have to find derivative of this function. So for that, what I need to do is first I have to square the denominator, that is v square, and the same denominator should be taken over here, times, now I have to get the derivative of the numerator u, that is u prime. Then I have to take a negative sign. Now I have to keep the numerator u as it is, times I have to get the derivative of the denominator v, then it's a v prime. So this is called coefficient rule. So the same thing I have to apply in our function to get the derivative with respect to x, that is to get dy over dx. Okay, now let me write the given function over here, that is y is equal to x over cosine x. Okay, so now on the left side, if I find derivative of this y with respect to x, it will become dy over dx. On the right side, we have to apply coefficient rule. That is, first I have to square the denominator, then I'll be getting cosine x the whole square. Now the same denominator cosine x should be taken over here, times, now I have to get the derivative of the numerator, that is x prime. Now I have to take negative sign. Now I have to keep this numerator x as it is and get the derivative of the denominator, that is cosine x prime. Dy over dx equals to cosine x times, when I find the derivative of this x with respect to x, it's just 1. So cosine x times 1, negative x times, when you find the derivative of cosine x, it will become negative sin x. And in denominator, I have to write the cosine x the whole square as it is, that is cosine x the whole square. Okay, let me continue over here. Dy over dx equals to, so cosine x times 1, just cosine x. And so here negative times it will become positive x times sin x over cosine x the whole square. Okay, dy over dx equals to, okay, now let's look at the previous step over here. That is, so here two terms are in addition in numerator, and cosine x whole square is a common denominator for the addition of these two terms. Whenever we have a common denominator for addition of two terms, what we can do is we can take this denominator separately for the first term and separately for the second term, and then we have to add the two fractions. Then I'm getting cosine x over cosine x the whole square positive x times sin x over cosine x the whole square. Okay, in my next step, dy over dx equals to, so cosine x over this cosine x whole square can be written as cosine x times cosine x, and we can split up this fraction as x times 1 over cosine x times sin x over cosine x. So even if I multiply these three quantities, I'll be getting this stuff. So because x times 1 is x, x times sin is x sin x. I'm getting the stuff in numerator. So when I multiply cosine x and cosine x, I'm getting cosine x whole square. So I'm getting the stuff in denominator. Now I can cancel this cosine x over here. Then I'm getting dy over dx equals to, here this is 1 times and this is 1 times. So I'm getting 1 over cosine x here. Positive x times, using reciprocal trigonometric identities, we get 1 over cosine x equals to secant x. So we get secant x for this 1 over cosine x. And using coefficient trigonometric identities, I'm getting sin x over cosine x equals to tan x. So times tan x. So further dy over dx equals to, so already we know that using reciprocal trigonometric identities, we know that 1 over cosine x equals to secant x positive x times secant x times tan x. So the derivative of the given function is secant x positive x times secant x times tan x. So the correct answer choice for this question is option D.